Students of Universitas always uphold humanistic values and live in harmony in the surrounding communities. The students also make positive contribution to the communities. For its contribution to the world, Universitas Airlangga continues to make efforts and take a more significant role in global civilization's development. These are conducted through collaborative researches, international partnership, teaching session, and various community services. All of these efforts are derived from the spirit and the values from Universitas Airlangga motto, excellence with morality. It acts as the foundation for every element of the academic community in Universitas Airlangga to achieve the just and civilized global society. Universitas Airlangga in numbers: 6 campuses, 15 faculties, 1 postgraduate school, 174 programs, 44 bachelor degree programs, 46 master degree programs, 15 doctoral programs, 7 professional programs, 33 medical specialist programs, 8 medical subspecialist programs, 18 3-year vocational programs, 3 4-year vocational programs, Universitas Airlangga grows together in synergy with other top Indonesian universities to create a positive academic environment in its campuses. Universitas Airlangga is situated near to the public facilities such as sports centers, shopping centers, hospitals, police stations, and other public places which greatly support the educational process. The main campuses are located near to the city center of Surabaya, the vibrant city that also allows Universitas Airlangga to pay attention on its greenery. It is shown by an extensive concern on public parks and cleanliness. It creates a comfortable and refreshing atmosphere for the students during their studies. Despite living in modern and advanced city, students of Universitas Airlangga always uphold humanistic values and live in harmony in the surrounding communities. The students also make positive contribution to the communities. For its contribution to the world, Universitas Airlangga continues to make efforts and take a more significant role in global civilization's development. These are conducted through collaborative researches, international partnership, teaching session, and various community services. All of these efforts are derived from the spirit and the values from Universitas Erlangga motto, excellence with morality. It acts as the foundation for every element of the academic community in Universitas Erlangga to achieve the just and civilized global society. Universitas Erlangga in numbers: 6 campuses, 15 faculties, 1 postgraduate school, 174 programs, 44 bachelor degree programs, 46 master degree programs, 15 doctoral programs, 7 professional programs, 33 medical specialist programs, 8 medical subspecialist programs, 18 3-year vocational programs, 3 4-year vocational programs, Universitas Erlangga grows together in synergy with other top Indonesian universities to create a positive academic environment in its campuses. Universitas Erlangga is situated near to the public facilities such as sports centers, shopping centers, hospitals, police stations, and other public places which greatly support the educational process. The main campuses are located near to the city center of Surabaya, the vibrant city that also allows Universitas Erlangga to pay attention on its greenery. It is shown by an extensive concern on public parks and cleanliness. It creates a comfortable and refreshing atmosphere for the students during their studies. Despite living in modern and advanced city, students of Universitas Erlangga always uphold humanistic values and live in harmony in the surrounding communities. The students also make positive contribution to the communities. For its contribution to the world, Universitas Erlangga continues to make efforts and take a more significant role in global civilization's development. These are conducted through collaborative researches, international partnership, teaching session, and various community services. All of these efforts are derived from the spirit and the values from Universitas Erlangga motto, excellence with morality. It acts as the foundation for every element of the academic community in Universitas Erlangga to achieve the just and civilized global society. Universitas Airlangga in numbers: 6 campuses, 15 faculties, 1 postgraduate school, 174 programs, 44 bachelor degree programs, 46 master degree programs, 15 doctoral programs, 7 professional programs, 33 medical specialist programs, 8 medical subspecialist programs, 18 3-year vocational programs, 3 4-year vocational programs,
Okay. Is my voice is clear enough?
I think it's clear. You can go on, Miss
Okay.
Miss Asri.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, and welcome to our guest lecture delivered by Dr. Halidi Ali Lyeme, hosted by Department of Mathematics, Faculty of Science and Technology, Universitas Airlangga. With this special topic is goal programming and its application. First, let me introduce myself. My name is Asri Bhakti Pratiwi. I am the lecturer from Mathematics Department. I will be responsible for hosting this lecture. Before we start our main agenda, on behalf of Universitas Airlangga, I would like to welcome to Dr. Eridani, who is a Vice Dean of Science and Technology faculty, to deliver a welcome speech in this lecture. So please, Dr. Eridani, time is yours.
Thank you very much, Miss Asri. Is my voice clear for you? Okay. Okay.
Yes, it's clear.
Yeah. Thank you, our guest from Muslim University of Morogoro. Okay. I don't know the exact locations of your university. Okay, but maybe I hope I can know the location after this. Okay. As a welcome speech, I think we have a benefit to to attend your speech in here. It's about the goal programming and its applications, especially when maybe we can conduct some joint research or maybe joint publications with our lecturer in here. This is the new topics, I think. But moreover, maybe we can not only for the joint research or joint publications, maybe we can conduct some staff or student exchange, maybe for several weeks. I think it's enough for us to gain some experience to your institutions. I hope we can talk it later maybe. I hope Dr. Asri will be serve as a representative of our faculty maybe. Last but not least, I hope all of the audience will be gain some positive experience to know just a little about these topics. Maybe our guest will be told us about the lecture, about the books or maybe papers we can read after these presentations. I hope we have some new experience after this lecture. And after this, we will attend the speech with very serious. Even in Indonesia, today is a holiday, but today is holiday. But I think we will come to the serious situations in holiday. Okay, thank you very much, and I will go to Miss Asri to we can go on to this lecture.
Okay, thank you, Dr. Eridani, for the welcome speech. I guess right now, before we go to our next session, please all the participants turn your camera on, and we will have a photo session for the documentation. Femi, ada Femi?
Yes, Miss.
Okay, you can start to take a picture from the first slide until the last, yeah.
Okay, let me start in one. Wait, on cam?
Okay, please, all the participants turn the camera on.
Okay, everything is fine. Everybody looks silent.
Then Femi.
Okay, I take picture in 1, 2, 3. 1, 2, 3. 2. 1, 2. Done it, Miss.
Okay, thank you. Okay, today's speaker is Dr. Halidi Ali, and I'm going to read his CV first. Okay, Dr. Halidi is senior lecturer, especially in applied mathematics at Muslim University of Morogoro, Tanzania. Besides as senior lecturer, he is also the dean for the science faculty since 2017. He got his PhD in mathematical and computer science and engineering from Nelson Mandela African Institute of Science and Technology in 2017. He has publication in applied mathematics areas such as multi-objective optimization. He also collaborated in some journal reviewers. So please welcome Dr. Halidi.
Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
First of all, I would like to thank the Almighty Allah who gave us this chance to meet with you and make this presentation. Secondly, I would like to thank Professor Dr. Nani Kiaisha, who came to us last month, I think. It was early in this month, on 5th of July. She presented in the Department of Chemistry some of that is where we start to communicate, and then we make this one possible. So I'd like to take this opportunity to start to present my presentation, that is goal programming and its application. So I would just pass through because the topic itself is huge, but I try my level best to pick something which is very important, so at least some people get some insight on the topic. So the topic is goal programming and its application. So the outline will be, we'll start with an introduction, then the theory of the goal programming. Of course, we'll discuss about the general programming models. In this case, we have about 3 model: preemptive or lexicographic goal programming, weighted goal programming model, and we have the Chebyshev goal programming model. And then we'll see the goal programming solution methodology in which we can solve the problem. And later on, we'll see some of the application area of the goal programming. And probably we'll see some sample problem, how to formulate, and at the end, we'll see the conclusion. So to start with the introduction, the goal programming technique has become a widely used approach in operation research. So we know the subject operation research has been started in many years ago, especially before the World War II. That is where the image of this operation research started. So during the World War is where the American Force Arm and UK, where they started to allocate their limited resources to different military missions. That is where the starting of the operation research has been begun. So the technique was first used by Charles and Cooper in 1960s. Of course, these 2 persons, we call them the fathers of goal programming because they are the first person who started to use the goal programming. So the model and its variant has been applied to solve large-scale multi-criteria decision-making problem. Of course, it comprises with the large-scale multi-criteria decision-making problem. So the problem should be a large one and not that one which is very, very simple. So the goal programming is one of the models which has been developed to deal with the multi-objective decision-making. So it's just involving the decision-making problem, because the decision maker are normally wanting to get insight of a certain things before they make decision on the given problem. So therefore, we can conclude by saying that the technique is an analytic framework that is the decision maker can use to provide an optimal solutions to multiple and conflicting objective problems. So it should be multiple and also conflicting, because the problem could have a multiple but not conflicting objective. That is the interest of this goal programming. So therefore, the theory of goal programming, what is the theory behind? So we know that the linear programming, because the goal programming has been derived from the linear programming, which is very common one. So the linear programming is able to handle the optimization problem of various aspects, such as economics, management, production mix, military, scheduling problem, planning. It's so many areas we can be applied in the linear programming. So however, there are a lot of limitation to linear programming. What? Linear programming problem, normally, when you are solving the problem, it needs to satisfy all the constraints. While in real life problem, not all constraints need to be satisfied, because some of the constraints you may satisfy them, but the other one could not be satisfied. So that is the one of the drawbacks of the linear programming. That's why we seek to discuss this goal programming. Also, the linear programming treats all constraints as equally important, while in practical, importance of each objective is different. So the linear programming normally treats the constraints as equal. It does not consider whether the importance of the objective. So that is another drawbacks of the linear programming. And also linear programming always find the optimal solution of the problem, while in the real sense, many problems we just seek to find a satisfactory solution and not an optimal solution. So therefore, the goal programming is one of the mathematical tools designed in context of solving the multi-objective problem in different areas for taking the efficient, timely, and accurately. So general, we can say that the goal programming objective function does not contain decision variables. Instead, it contains the deviation variable that represent each type of goals or sub-goals. Of course, we know that the linear programming, normally it has a decision variable, whereby the model normally finds the values which will guide the decision maker to make a decision. So in the goal programming, we don't have decision variable, rather we have the so-called deviation variable, in which we can discuss later on what we mean by the deviation variable. So now, let us see the general goal programming model. So as we say that, according to Charles and Cooper in 1977, presented the general goal programming model which can be expressed mathematically as this one. So we have the objective function minimize z, that is summation from I to capital I. Then we have d sub I negative plus d sub I positive. So these d sub i's are deviation variable. It represents the underachievement and overachievement. The d sub I negative represents the underachievement of the objective or the goals, and the d sub I positive represent the overachievement of the goals. So that is the general objective of the goal programming problem. So subject to the linear constraints, of course, we have the linear constraints. Normally in the linear programming problem, we have the system constraints. The system constraints, it can be either less than or equal, or greater than or equal, or with an equal sign. But in goal programming, we have the goal constraints. So these goal constraints taking care the objective of the goals, or the goals of the organization. As we say that, it has multiple objectives. So it depends how many objectives you have, whether 2 objectives, 3 objectives, 4 objectives, 5 objectives, it depends how many are they. So that is goal constraints is the one which taking care those objectives. And lastly, we have the non-negativity constraints, of course, with d sub I, negative d sub I, positive x sub I greater than or equal to 0. These are the non-negativity constraints. So we just define The Z is just an objective function. A sub I sub j is the coefficient associated with the variable j in the ith goal. X sub j, the j's decision variable. Of course, that's one is the decision variable. B sub I is the associated right-hand side values. Normally, this one is the limitation which has normally been given when you have been given a certain problem. And D sub I, as I say, negative deviation variable from the ith goals, or we call it an achievement. And D sub I positive is a positive deviation variable from the ith goal, which will mean that the overachievement. So both overachievement and underachievement of goals cannot occur simultaneously. Hence, either one or both of these variables must have a 0 values. So you may see the table below, it just gives the procedure for achieving a goal. So if our goals is to minimize the underachievement, then we are supposed to minimize D sub I negative. So if goal is achieved, the D sub I or negative achievement or negative deviation variable should take the value of 0, while the positive deviation variable should take the value of greater than or equal to 0, if we want to achieve the goal for minimize the underachievement. So the same case for the case of positive deviation variable. We want to minimize the overachievement. So then the positive deviation should be equal to 0, and the negative achievement should be greater than or equal to 0. So if our aims is to minimize both over and other achievement, so in order to achieve the goals, then both positive deviation and negative deviation, their value should be equal to 0. So now, having seen the general goal of programming model, now let us see in the goal programming we have about 3 models. The first one, we call it preemptive, or sometimes we call the lexicographic goal programming. So in this case, it is often challenging for a decision maker to accurately ascertain the exact relative significance of the objective. Because in the goal programming, normally, the decision maker is supposed to give the priority or to give the weight of each objective, because the problem contains some multiple objectives. So therefore, you have to make the rearrangement of your objectives so that at least you can rank them. So applying the preemptive goal programming, the decision maker must rank his or her goal from the most important to least important. So you have to rank the goals from the first one to the last. So the preemptive goal programming procedure starts by concentrating on meeting the most important goal as close as possible before proceeding to the next higher goals, and so on the least goal. So we normally start to achieve the most important goals, then follow the second, the third, and up to the least goal. Here, we have to assume that no 2 goals have equal priority. So of course, each goal has its own priority. So once you rank them, so you have to achieve them according to their length. So that means that the lower order goals are only achieved as long as they do not degrade the solution attained by the higher priority goals. So we have to make sure that if the second or the third goals, if you attain that one, if it will affect the first goal, that one is not possible. So you have to make sure that the first goal first attained, then second, the third, and then the fourth one. So this is an example of the preemptive lexicographic goal programming, the general. So the model can be stated as minimize Z, that is the summation I from 1 up to capital I. Then we have P sub I, and then we have the positive and negative deviation variable. Of course, that P sub I is the preemptive priority factor of the ith goals. So we give priority to our objective function. Those objective function, we rank them. The first priority, then the second one, the third, the fourth, and etc. etc. So it depends how many priority you have. So that is the general preemptive or lexicographic goal programming. Another model, we have the weighted goal programming model. If the decision maker is more interested in direct comparison of the objective, then weighted goal programming should be used. So you have to take note here the difference between the preemptive and the weighted goal programming model. So something could be priority, but its weight is not large enough. So here we are just considering the weight. So the weighting of deviation variable at the same priority level show the relative importance of each deviation. According to Charles and Cooper, 1977, stated the weighted goal programming model is given in equation 3, where we have the positive and negative weight are non-negative constants representing the relative weight to be assigned to the respective positive and negative deviation variable. So the relative weights may be any real number, where the greater the weight, the greater the assigned importance. So it means that the objective which has got the greater weight, it means that it has assigned the highest importance, of course. So here is the general weighted goal programming model. So minimize. So we add the negative weight and positive weight to the decision variable. Positive and negative deviation variable. So subject to the goal constraints and to the same system constraints. So that the difference you can note here is that we have the W sub I negative and W sub I positive, which has been signed to both positive and negative deviation variable. While in the preemptive, we just add P sub I to the both positive and negative deviation. So there is someone called Ijiri in 1967 had introduced the idea of combining preemptive priorities and weighting as given below. So he just combined both two models, the preemptive and the weighted goal programming, to get one model. So that's why you see that's minimize Z, then you have double summation, of course. We have P sub I in bracket, then we have W sub I K positive and D sub I negative plus W sub I sub K positive and D sub I positive. So we just combine two mode, of course, the preemptive and the weighted goal programming. So that one is subject to the linear constraints, that is goal constraints and system constraints. So that W sub I K positive and negative represent the relative weight to be assigned to each of the K different classes within the category of which the non-Archimedean transcendental value of P sub I is assigned. So you must assign the weight of each objective so that it could be easy for a decision maker to make a decision. That the higher the weight, the importance of the objective is. So there must be the assignment of those weight to the given objective or goals. Then the last one, we have the Chebyshev goal programming model. So this one is sometimes we call the fuzz programming model. This one was introduced by Fravel in 1976. It uses to minimize the maximum unwanted deviation variable rather than the sum of the deviations. So in this case, it just considers only the unwanted deviation variable, because we have two types of deviation variable, that is negative or underachievement and the positive, which is overachievement. So if our target is only to maximize the unwanted deviation variable, then we can use the Chebyshev, because the two methods preemptive and weighted goal programming, they just consider the sum of this deviation variable rather than only one deviation variable. So for this reason, shape goal programming is sometimes termed minimax goal programming. The utilization of the distance metric, which emphasizes justice and balance rather than ruthless optimization. Of course, this one, it gives us the justice and the balance of those deviation variable rather than ruthless optimization, as it has been done for the case of the preemptive or weighted goal programming. So, but in other words, the preemptive lexicographic goal programming model in equation 2 and the non-preemptive weighted goal programming model in equation 3 can view as the two extreme types of goal programming model in which virtually all goal programming model are derived. So those two are the most used goal programming which has been used before the existence of the other one. So now let us see the goal programming solution methodology. Of course, there are many different methodologies and the algorithm used to generate solution for goal programming models. But in our case, we will begin by categorizing them into 4 groups. Of course, the first group, we have the linear goal programming, which include all linear-based goal programming solution methods. And the second one, we have the integer goal programming, which include methodology used to generate all integer, mixed integer, and 0-1 integer solution. And the third one, we have the nonlinear goal programming, which include all nonlinear based goal programming solution methods. And lastly, the final group for all methodology that does not fit into the other 3 groups. So that one is the 4th methodology. So of course, in this one, we have so many algorithms, of course. For the case of the linear, we normally use the simplex methods, which is very common used, and it has some software which can be used to solve the problem. Of course, in this case of the integer, again, we can use those simplex methods. That is a very common one to accommodate the problem with a huge number of variables rather than using the graphical methods. So the graphical methods is a very common one, but it is normally used when you have only 2 variables. While in real life problem, you cannot have only 2 variables, rather more than 2 variables. So we apply the simplex algorithm to solve this problem. So what are the application area of the goal programming? So in general, the goal programming model performs 3 types of analysis. First, it determines the input requirement to achieve a set of goals. Of course, normally you have the input requirement for the model so that it can give you the output. So normally people are saying garbage in, garbage out. So it determines the input requirement so that to achieve a set of goals, what is your planning? What is your expected product? So that is how the goal programming can be applied. So the second one, it determines the degree of attainment of defined goals with given resources. So the degree of attainment can also be determined by the goal programming. Of course, there must be a defined goals with the given resources. So those are some sort of the limitation which can be set to be when you are developing the model. Also, it provides the optimum solution under the varying inputs and goal structure. So the goal programming approach should be carefully examined by the decision maker before the use of the techniques. Why we say this one should be carefully examined? Because if you fail to set the goals, you'll also not get the required solution. So you'll make decision or you make a bad decision. So that's why it should be very carefully examined before the decision maker use this technique So to give the priority or to give the weight to the problem, or due to the organization or institution objective, then you have to set this one very careful so that at the end of the day, the solution should be reflected to what the institution or the organization needs. However, if the decision maker goal priority are not in accordance with the organization objective, then the solution will not be the global optimum, rather will be specific focus on the organization. So in the solution, we have the local optimal solution and we have the global. So the global one will be, it can be used, it means that in several areas, that the solution could be used. But that one should be careful, the decision maker make those priorities so that the solution at least will be global. So we continue with the application area. So the following three are the most readily applicable area of goal programming. The first one, we have the allocation problems. This is one of the basic decision problems in the optimum allocation of scarce resources. So we may just make an assumption that you have n different input resources that are limited to a certain quantities, and there are m different types of output that result from various combinations of these resources. So the decision problem in this is to analyze the optimum combination of input resources to achieve a certain goal set for output so that the total goal attainment can be maximized for the organization. So you have thus n different input resources, and you have m different types of output. So we just considering the decision problem here is how the combination of these input resources so that we can achieve a certain goals set by the organization or institution so that to maximize the organization requirement. So that is the allocation problem. So you have a certain resources, then you want to allocate. In actual fact, normally the resources is scarce. So we want to allocate them in such a way that we satisfy all the expected or the set objective or the set goals of the organization. So the second application area is planning and scheduling problem. So many decision problems involve some degree of planning or scheduling. In order to achieve certain goals in the future, the decision must be made concerning present and further action to be taken. So therefore, the goal programming could accomplish this task. So you can make a planning for the future for your organization or your institution so that you can attain a certain goals which you plan. So to accomplish this, the desired output, the optimum combination of inputs in a certain time period must be well identified. This input may include, of course, manpower, material, time, production, capacity, technology, etc., etc. So many of them, it depends what things you plan to do in the future. The problems such as production scheduling, location determination, financial planning, personnel planning, marketing, strategy planning, etc., can be analyzed by the goal programming. So in scheduling, for instance, you may take an example of nurse scheduling in the hospital. So you may plan to schedule the nurse according to their shift, maybe morning shift, evening shift, afternoon shift. Some of them, they have the night shift, and some of them, they have the leave, of course, the normally off days and so forth. So you can make that one as a scheduling problem to solve the organization problem. So the third application area, we have the policy analysis. So the policy analysis, of course, this can be done for the case of the government as well as the non-governmental organization. Normally, they formulate the policy based on this one. So the goal programming problem, the goal programming model can be used to analyze the policy. So this involves the review and the evaluation process is an integral part of policy analysis. So you make some evaluation and the review so that you can make the policy analysis. So this normally can be achieved if you can considering the policy analysis, of course, can be considering when you are doing the goal programming model. So there are several problems related to the policy analysis, and we can see later on. So before we see the sample problem, though the application area of goal programming is many as in linear programming, so we just simply mention the three area, which of course contains several area you can chip in, but the application can be as large as the linear programming application. So not only these three, but rather we can consider so many of them. So here we have the sample problem, in which we have a problem so that we can use the goal programming to solve this problem. So we have the HHR computer company produces three types of computers: computer type A, type B, and type C. So the production of all computers conducted in a complex and modern assembly line. So the production of type A require 5 hours in the assembly line, type B require 8 hours, and type C requires 12 hours. The normal operation line of the assembly lines is 170 hours per month. So the marketing and accounting departments have estimated that profit per unit for the three types of computers are USD 1,440, I mean 1,044 for the type B, and 2,552 for type C. So the market department further reported that the demand is such that the company can expect to sell all the computers it produces in the month. So that is the problem. So the CEO of the company has established the following goals according to their importance. So it gives us the priority of the goals. So the first one, the CEO said that we must avoid underutilization of capacity in terms of regular hours of operation of the assembly line. So you remember that here the assembly hour we have been given is 170 hours. So that one is the first priority, that we have to make sure that we avoid underutilization of these hours in the assembly line. So the second priority, it gives us thus meet the demand of Eastern Sales District for 5 types of A, computer type A, 5 type B, and 8 type C. So that is the demand of the cells. So we must make sure that we meet this demand. So the third one limits overtime operation of the assembly line to 20 hours. Of course, as far as the overtime is concerned, normally it affects the company earnings. Of course, if you have so many overtimes, it means that all the profit will be eaten by the overtime. So we have to make sure that we limit overtime in that assembly to 20 hours. Then the fourth one, meet the sales goals for each type of computer. So each type of computer, it has the goal has been set. Type A, we have to sell at least 10 computer. Type B, 12 computer, and type C, 10 of them. And the last priority, minimize the total overtime operation of the assembly line. So those are the priority which has been given by the CEO of the company. So now we're supposed to make the to formulate this problem. Of course, we normally in formulation of the problem we have the basic three steps. Normally we define the variable and the constraints, and then we formulate the constraints, and then we have the general model. So in our case, we easily set up the goal programming model for the above problem as follows. First of all, we define variables and constraints. In this problem, we have, or we let x sub 1, x sub 2, and x sub 3 be the number of type A, B, and C computers, respectively. So we have 3 types of computers. So we let x sub 1, x sub 2, and x sub 3 to represent these types of computers. So the constants are given in the set goals. Of course, when we say the constants, we mean that's those limitations which has been given in the problem. Of course, the CO has already given us the objective and set some of the constant, of course, which will use them to the constraints, normally the right-hand side constraints. So then the next step is to formulate the constraints. We can formulate the normal, of course, in the constraints. In our case here, we have, at least 3 of them, of course. We have the constraints related to the operation time, and then we have the constraints related to the cells. In the cells, we have the demand, and of course, we have the goals. And we have the another constraints concerning the over time. So now, we will start with the first constraints, which contain with the normal operation capacity of the assembly line. So in the problem, we were told that the computer type A normally use 5 hours in the assembly line, and type B use 8 hours, and type C use 12 hours in the assemblies. So of course, we don't know how many computers will be produced. That's why we give the object, the decision variable x sub I sub 2, x sub 1, x sub 2, and x sub 3 to represent the number of the respectively computer. So therefore, the constraints will be 5x1 plus 8x2 plus 12x3. So as far as the goals is concerned, we have 2 deviation variable in this case. We plus negative deviation variable, and then we subtract positive deviation variable, and we equate them equal to 170 hours, because that is the normal operation capacity of the assembly per month. So that will be the first constraints which contain, which relate to the normal operation capacity, where of course D sub 1 negative is underutilization of normal operation hours, and D sub I positive over time operation of assembly line. So we have to remember that we were asked that not to underutilize the normal operation hours. So that is the first constraint. So the second constraints, of course, we have the sales constraints. In this case, we have the demand from Eastern District. We remember that the CO tell us we must meet the demand of the Eastern cells. So the demand of Eastern cells, we are told that's 5 type A computer, 5 type B computer, and 8 type C computer. So we have X1 plus, of course, their respective decision, deviation variable should be equal to 5. X sub 2 plus the respective deviation variable is equal to 5 for type B, and X sub 3 plus the respective deviation variable is equal to 8 for type C. So that one will meet the demand from Eastern District, the sales constraints. Of course, we have another sales constraints, which is related to to the sales goals. The computer also have sales goals for the month, which we formulate as follows. Of course, for the type A, we are supposed to sell at least 10 computers, type B, 12, and type C, of course, 10. So the respective constraints are given above, that x sub 1 plus the respective deviation variable. And for type A, for type B, we have x sub 2 plus the respective deviation variable d sub 6 and d sub 6 positive and negative, respectively. And for the type C computer, we have x3 plus d sub 7 negative minus d sub 7 positive is equal to 10. That one will be the constraints for the sales goals. And then we have the last overtime constraints. So the CO listed the minimization of overtime operation of the assembly line to 20 hours. In this problem, we do not have deviation variable to minimize in order to achieve this goal. So we introduce the following constraints. We have the deviation variable d sub 1 positive plus d sub 11 negative minus d sub 11 positive is equal to 20. So we introduce this d sub 11 positive and negative so that we can minimize that deviation variable of d sub I. So the d sub 11 negative is the difference between the actual overtime operation of the assembly line and the allowed hours of overtime operation. Of course, we have the difference here. We have to meet, of course, the CO tell us we have not to exceed the overtime hours more than 20 hours. So that's why we say that the difference between the actual overtime operation of the assembly line and the allowed hours of overtime operation. So we'll check the difference between this one. And the D positive, of course, is the overtime operation of the plant in excess of 20 hours. So that is the overachievement. So it means that you'll exceed that 20 hours which has been set by the plant CO or the company CO. So thus the problem can be formulated as goal programming model as follows. So we have this objective function. In this case, we have the minimize Z, we have P sub 1, that's the priority 1. Of course, priority 1 related to the, if we remember this one, the priority 1, we can see here, the priority 1 to avoid underutilization of capacity in terms of regular hours of operation of the assembly line. So that's why we put this one as a priority 1, and we consider this D sub 1 negative, because that's one is the underutilization. So that's why we want to minimize that one, because the CO tells us we are not supposed to underutilize the operation capacity. So the second one, we have 20 P sub 2. Of course, P sub 2 is the priority number 2, which is comprises the cells in the Eastern District. So why we put 20? We have, of course, priority number 2, given the 20, we have 18 and we have 21. Where we get this 20, of course, 20, 18, and 21. So we may see this one in the profit, where we were told that the profit of this, the computer will be sold by $1,000, type 1, type A, 1,440, this is type B, and the 2,552 for type C. So how we get this one, the coefficient we may get by dividing with the normal hour which has been used in the assembly. So we normally take, for instance, for type A, it will be sold for $1,000. So we divide by 5 hours, which will take in the assembly line. So we take 1,000 divided by 5, then we get 20. And if we take 1,440 divided by how many hours used in that one, in the of type 2 is 8. When you divide by 8, then you get that one 18. And if you take 2,005 and 52,000, I mean, if 2,005 and 52 divided by 12, you get 21. That is where we get this, we get this coefficient 20, 18, and 21 for constraint number, for priority number 2. So that one is associated with the negative deviation variable. Of course, D sub 2 negative, D sub 2 negative, D sub 3 negative, and D sub 4 negative, because we want to minimize the underutilization. So that's why you have all those negative deviation variable in the objective function. So the next priority is priority number 3. The priority number 3 is concerning with the goals of the cells. Constraint, priority number 2 was about the demand of the eastern district, but constraint number 3 is about the cells goals. Each types of computer, the goal has been set. We want to sell a certain number of computer in the company. So that one is where we consider the amount of computer which is supposed to be sold by the company. So again, on the priority number 4, which is comprises with the, priority number, let me check it clear here. Priority number 3. Priority number 3 is limit over time operation of the assembly line to 20 hours. And the priority number 4 is that one concerning the set goals of each types of computer. So that's why you have this coefficient again, 20, 18, and 21, because it comprises the 3 types of computer, and the coefficient as we have been explained before, how we get this 20, 18, and 21 by simply dividing the cells by the hours which the computer has been passed through the assembly line. Then you get this 20, 18, and 21. Of course, and the last priority is to minimize the overtime, that is P5. And that's one is associated to the positive deviation, because we want to minimize the overtime, not exceed much. So that's why we are supposed to minimize. So therefore, this is the general objective of our goals programming. So this one will be subjected to those constraints which we have been discussed before. We have the overtime constraints, the sales constraints, and the normal operation capacity. And the last one, of course, will be the non-negativity constraints, in which we have those deviation variable, that is D sub 1, D sub 2, D sub 3, up to D sub 11 should be greater than or equal to 0. Then, having that model, then we can solve I normally use the software called the Lingo to solve the problem. So we can, I don't know whether we can have a time to type this one so that we can solve, at least we get some sample solution. Let me see whether I can share this. I can share this one also. Where is the lingo? So this is the software which I normally use to write the, so we can simply write the, oh. So I don't know here, it does not want to come. So maybe to make a conclusion, we can, so we can say that in this presentation, we have discussed a brief introduction of goal programming as a powerful tools to handle multiple and incompatible goals of any enterprises. We further discussed the theory behind goal programming as well as the general goal programming model formulation, as we have been seeing the three types of goal programming, that is preemptive, lexicographical goal programming, and the weighted goal programming, as well as the Chebyshev goal programming, or sometimes we call the FAS. And we discussed the solution methods of goal programming were also discussed. So the application area of the goal programming, we also briefly discuss them, though, as we say that the application is more widely as it has been used for the case of the linear programming problem. Thank you very much for your attention.
Okay, thank you. Okay, any question from the participants? You can raise your hands and ask directly to Dr. Halidi. Okay, Doctor, and this is a quite interesting topic. In our
Yes.
study program, we only have a course in linear programming and then integer programming, integer linear programming. So this goal programming is quite new for us. So I have several questions. When we decided that if we have a sample problem, we can take this problem to the goal programming model. I mean, when we discuss about hospital scheduling problem, it's actually we can take this problem into integer linear programming. But when we decided that this is, I think this is we can bring or we can take to the goal programming model.
Okay. Thank you very much for your good question. Of course, as I explained before that the goal programming, normally you must have a multiple objective. Once you have a multiple objective, you want to achieve them, that is where you can use goal programming. For instance, you may take an example. For instance, it's a nurse scheduling problem. You want to minimize the cost for employing more nurses. At the same time, you want to minimize the time for them to attend in different wards. So in this case, you have at least two objectives. So that is where you can use the goal program in order to achieve both two goals at the same time without affecting any of them.
Okay.
Yeah.
Okay. Comparing with some method, with some method, yes. We usually add some weight for the variable. So, which one do you think is better?
What, can you repeat your question?
Some of the researcher, if we have a multi-objective optimization, we use the objective function using the weighted sum method. weighted sum method.
Weighted sum method, yes.
Yeah,
You know
so
that.
we can add weight to the each variable in the objective function.
Yes.
So which one do you think is appropriate or better if we have a multi-objective optimization? Do you think we have to use this goal programming, or we can use only weighted sum method?
It depends on the nature of the problem.
Okay.
Because each nature of the problem, each methods normally are used according to the application of it. The weighted sum is good, of course, but there are sometimes where you have a conflicting objective. The conflicting objective, that is where you must use the goal programming.
Okay.
Because the objectives are conflicting. So we want to solve them. So in such a way, each one should not conflict with the other so that we attain the required objective.
Okay. Okay. Thank you. Any question from the audience? Silakan. Kemarin kan sudah dapat PLI sama program linear ya. Kalau ini goal programming. Jadi fungsi tujuannya itu lebih dari satu. Silakan, any questions? Pak Muhammadun, Mr. Muhammadun?
Oh, yes. Suara saya terdengar?
Ya, terdengar.
Prof. Halidi,
Yes.
I'm actually still new to this topic.
Okay.
So what I want to ask, are there any tools or software that we can use to solve the goal programming problem?
Yeah, there are so many tools, of course. Normally the tools which has been used to solve the normal linear programming problem is also used to solve the goal programming. In my case, I normally use, I don't know whether you know the MATLAB.
Yes.
MATLAB we can use, and we have Lindo, we have Lingo, we have the GLPK. Of course, this one are normally used for the OS. Normally, it's used for Ubuntu. That is open access. Of course, that one is very useful because the other software are normally used for, you have to buy the license. But this one, the GLPK, is the free, so you can use at any time in any place for any number of variables. So there are so many of them which can be used to solve the goal programming. And you have to take note that the goal programming is rather the formulation, but the concept of linear programming remain the same. It's just the issue of formulating to a goal program, but the steps and the solution methods are just the same as for the case of normal linear programming problem.
Thank you, Prof. For the second question, could Prof. Halidi please to provide insight to us regarding research opportunities for goal programming research?
Okay.
Especially maybe for appropriate to use as dissertation topic.
Okay.
Yes.
So anyway, I'll provide those things because currently I'm working with 2 students from the other university, and one of them we are doing of course, the nursing problem, and the other one we are doing the optimization of the nutrients, food. Of course, she want to prepare food for children or HIV/AIDS. So normally we have the multiple objective problem in which I use the goal programming to solve. So I will share those topics to you so that we can collaborate together.
Thank you very much.
Thank you.
Okay, any more questions? So how about the method to solve the model? Can we use the simplex method to solve this goal programming model?
Yes, you can use, yes, you can use simplex methods. That is very common one.
Okay.
Of course, all the tools which we are using, they are using simplex methods.
In here, we use the WinQSB program software.
Okay. Oh,
Okay, any more questions? I guess we still have more time, doctor, if you want to simulate the Lindo.
can try to simulate, yeah, no problem. Let me see how can I have some, or maybe let us open some sample problem here in Lindo. So of course I have this one sample. I don't know whether it can run here. Yeah, it runs the sample problem. It's just there. Let me expand this. Increase the size. I don't know whether you see this one. The objective is to minimize 4x1 plus 5x2 plus 2x3 plus 3x4. This one is subject to, we have these constraints, 4 of them. And if you go to these sites, want to run this one. I don't know why this one it is up here. You can run, once you run this, it gives you the solution. Of course, this one is the solution. So it gives us the global optimal solution found. The objective value is this one. Infeasibility, no infeasibility. Of course, if the model has got some problem in the infeasibility, you get some numbers which show that your solution is not optimal. So if it gives you 0, it means that the solution is feasible. So it tells us even the total iteration to run only 2 iterations. So you know in the simplex methods algorithm, we have some iteration. So it go that's 2 iteration. And then it gives us the elapsed time that is 0.7 because the problem is very, very, very small. And here it gives you the solution, of course, on the decision variable. So we have x1, the value of x1 was 0, x2 is 5, x3 is 2.5, and x4 is 0. Of course, in this case, we have the slack duality price reduced cost in the, in the simplex table. Normally, these things are very important to have the reduced and so forth. So that is the software which I normally use, the lingo. And if you have seen one of my paper in Google Scholar, I just use the paper titled Implementation of Goal Programming Model for Solid Waste Management, a case study of Dar es Salaam, Tanzania. So I use, of course, in that paper, you may see that I just even give the steps on how we can formulate this goal programming. So I may share this paper. Let me see in my stock here. Just share this paper. Here it is. Let me download. It is. Here is the paper. So you may see this one is the implementation of goal programming model for solid waste management, case of Dar es Salaam, Tanzania. So I may just go straight to the model, because here is the model. The model has 3 objectives, of course. The first objective, this one, minimize Z sub 1, and then the second objective is to minimize this one, second objective. You may see here so many calculations. So many sum. Objective function, the first one, this one. Just we define this one. The second objective was to minimize. This is the second objective. And we have the third objective. So you see that we have 3 objectives. The first objective was to minimize cost. The second one was to minimize the greenhouse gas emission. And the third one was to minimize the amount of waste to be sent to the dump site. So there are 3 objectives. So then we decide to use the goal of programming. That is where you formulate by using the deviation variable. So in our case here, we have this objective number 3, where we want to minimize this deviation variable number 2, and of course this is overachievement and underachievement. So then in the conclusion, we have 3 models. Of course, the first one, we meet the first objective to minimize the cost. So we solve that one, then we get the minimum cost. Then having that minimum cost, then we take that one as the constraints, so that to make sure that while we are finding the second objective, we don't deteriorate the first objective. So that's why the first objective value should be taken as the constraints in order to to keep it as we get from the first one. So, and then once you get the solution for the second objective, that value should be taken as a constraint. And then you go to the last objective, so that at the end of the day, you get. And we have seen here, for instance, in this case, we have this deviation variable value almost zero, all of them. So it means that the objective has, all goals has been achieved based on the fact that the deviation variable are equal to zero. So finally, we see that we meet all the three objectives without compromising one of the other. So that is the important things which we normally do. So this is the paper which has been published in 2017, I think. It was in 2017, and I have several of them. Of course, currently, I have some few students in PhD and masters who are doing the same optimization, and specific in the goal program. So you may get this paper is free access. You may download it and then you may use it. And if you have any question regarding any of my paper, you may ask me. Yes. Any concern?
Okay, we have a question from the textbook, Doctor. If we translate back the result of goal programming into the first model, how we describe the term of slack, surplus, and dwell prices? Is it the same as the other linear programming program?
Yes, of course, the same. The same as in the linear programming. Of course, we know that the general linear programming, it has a drawback, because the linear programming, normal linear programming, is only focused on one objective and forget the other objective. While in the real life problem, as we say, that we normally have several objectives to accomplish the organization or institution objective, the institution goals. So that's why the use of the multiple objective problem is rather useful compared to the single objective. So the linear programming, single linear programming problem has a drawbacks or limitation.
Okay. Any other questions? Is it clear, Ms. Uma? Okay. Okay, any other question from participants? No? Okay, I guess the challenging part is how we determine the model. I guess the challenging part is how we determine the model.
How we determine the model?
Yeah.
I don't get you.
So is the goal programming is suitable if we have the variable solution in binary?
If we have where
The variable decision variable in 0 or 1. Is it okay, or is it possible?
yeah, it's possible because first of all, we normally have a general linear programming, and that linear programming is the linear programming with a multiple objective. So maybe you have 3 objective or 4 objective. On those model, you have the decision variable, of course. In the linear programming, you must have a decision variable. Of course, when we are talking about the model, we are talking about the decision variable, we are talking about the parameter. Of course, the decision variable is where the mathematical model or the model is interested to look or to find the solution of this decision variable. And we have the parameter. These parameters are given data whereby the model can use in order to generate the unknown. Of course, the decision variable are the unknown of the model, in which we are interested to find their values. And we have of course, the non-negativity constraints. So you will have those decision variable, but in the case of goal programming, we add another variable in which we call the deviation variable. And this deviation variable, we have the positive and negative. The negative represent the underachievement of the goals, and the positive indicate the overachievement. So it depends on our target. If we want to overachieve, so we have to make sure that we minimize this underachievement. And if we want to underachieve, therefore we have to minimize the overachievement. So they are deviation variable, which are only comprises in the goal programming. The other variable are there, but we concentrate on this because those one, as we run, of course, we get the solution to those decision variable, but our interest is on the deviation variable, because this one will give us based on the priorities of the objective or the goals given by the institution or the organization.
Okay. I guess looks like we have answered all the questions. Okay, Dr. Halidi, is there anything else you would like to mention before we end this course?
Okay, I think that's one. It is a good beginning. I hope that will continue cooperate in this area. Of course, my area of interest is on optimization. Of course, the goal programming is so specific, but I normally do in other part on the optimization. So I hope we may continue collaborate. If you have a student for the postgraduate, we can do the core supervision, and even here we have some few students we can also collaborate together. So I think this one is a good beginning.
Okay, thank you, Doctor. So I guess we are in the end of today's lecture. I would like to say thank you to Dr. Halidi. We wish that we can have another collaboration later in the future. And for all the participants, thank you for participating in today's lecture. On behalf of the committee, I would like to say sorry if there are any technical problems. So I hope to see you again next time. Okay, goodbye and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you,
Goodbye.
Doctor.
Thank you.
Thank you, Prof.
Thank you.